Okay, the next example that I want to discuss is from the guided tutorial module, yeah, the guided learning module. That is question 1B, yeah, question 1B and okay, this one here, 1B, as well as 1F. Of course, you have the answers down here, but the most important thing is you need to understand how to get the answers. Yeah, how to get the answers. All right, now let's begin with 1B. Yeah, continuation from what we have learned in the previous video. Okay, you need to remember all the steps involved. Yeah, you need to remember all the steps involved. By the way, don't go and memorize the steps like, okay, you memorize your biology and so on. No, yeah. If you do enough exercises, it will come to you automatically. Yeah, you will remember automatically. Now, so I have this structure. I'm going to redraw it in whiteboard so that you can see clearly and have a bigger image. Now, we have 5 carbons up here, and then somewhere in the middle, okay, 1, 2, 3, 4, 5, and somewhere in the middle, we have at carbon number 3, we have this group here, CH3, CH, CH3, yeah, right, this one here. Okay, at carbon number 3, we have 1, 2, 3. Now, okay, let's look at how I draw the structure of this compound. Always begin with the carbon chain and all other substituents and functional group. Finally, then only you fill in the hydrogens. Yeah, we have hydrogens here. You must count, literally count, so that you don't make any careless mistake. Okay, here we have CH3. Yeah, CH3. And then 1, 2, 3 bonds. Hence, we have 1 only here. And CH3 here. Okay, similarly, do the same thing for all carbons. Okay, CH3. And this one CH2, CH, and CH2. First step, as I mentioned before, identify the functional group. Is there any functional group involved here? Okay, no functional group, right? All you see are carbon and hydrogens. Yeah, carbons and hydrogens, which means this is just alkane and no substituent as well. Yeah, I mean no substituent like halogens and so on. Yeah, and then step 2. We go to step 2. Step 2, okay, step 1 check. Okay, no functional group. Step 2, okay, find the longest continuous carbon chain. Yeah, longest continuous carbon chain. Normally containing the functional group except for halogen. Alright, so let's begin. We have to look for all possibilities, right? Okay, I will try the linear one. 1, 2, 3, 4, 5. Right? So I have one possibility there. Okay, 5 carbons in a row. Or, okay, I'm going to use green now. Or maybe red. Yeah, red color. Okay, I want to make it bent. Yeah, a bent chain. Right, maybe 1, 2, 3, 4, 5. Yeah, still 5. And if I turn to the left, I also have 5. Yeah, 5 all the way. Either linear or bent chain. Okay, the longest is 5. So which one do we choose? Which one do we choose? Remember, when you have more than one possible carbon chain, then you choose the one with more substituents. Yeah, you choose the one with more substituents. Okay, refer to the orange one, which is linear. Yeah, which is linear. Okay, what do we do? Okay, with orange carbon chain, yeah, with orange carbon chain, how many substituent do we have? Right? Okay, I'm using orange now. Okay. If I use orange here, or if I take this as the parent chain, I only have one substituent, one branch. Ya, ada satu sahaja branch. Okay, so let's refer to the bent chain, the one in red just now. If I use this as my parent chain, either to the right or to the left, same thing. Okay, sama je. Or maybe I should go here. Either way is fine, no problem. Right. Jadi, bila begini, okay, how many substituents do we have? Okay, how do we know that yang mana substituent ni? Okay, yang tak termasuk dalam the parent chain itulah substituent. For example, in this case, the one in red is the parent chain. Therefore, we have 1 and 2 substituents here. Okay, so which one do we choose? Which one is the right one? The orange one, the linear one, or the red one? Right. So, we choose the one with more substituents. Tadi satu je substituent. But now, we have 2 substituents. So, this is the right carbon chain. Okay. Now, step 2, done. Okay, step 3. Okay, what do we do now? Number the carbon chain so that functional group and substituents receive lowest possible number. Okay, now kita try number the carbon chain from the left as written here. Jadi substituent dekat carbon yang mana? Okay, at carbon number 3 and at carbon number 4. Okay, 3, 4. But if we start from this carbon instead, ya. Okay, kita padam ini. Oops. Hold on. Okay. Okay. I'm going to use a different color now so that you can see, yeah, the difference. Okay, maybe yellow. 1, 2, 3, 4, 5. Okay, as you can see now, our substituent is at carbon number 2 and carbon number 3. Okay, 2 and 3. Which one is better? 2, 3. Which are lower than the one before, 3 and 4. So we choose the yellow one. Okay. So what we have on the screen is now correct. Yeah, the numbering is now correct. So we take it as the one from the right. 1, 2, 3, 4, 5. Okay, the next step. Okay, step 3 done, numbering. And then step 4, name the parent chain. Name the parent chain. It has 1, 2, 3, 4, 5. 5 is pentane. Yeah. Pentane, parent, kan? The name should be the last word. Yeah, the parent name should be the last word in the set lah, in the full name. Right? Just like our Ben and Benti lah. Okay. Then, next step. List all substituents. List all substituents. Okay, we have substituents at carbon number 2 and carbon number 3. Now, at carbon number 2, we have 1 carbon. So, it is called methyl. Yeah, methyl. We list them. We list the name of the substituent now. You separate number, yeah, and word by using dash. Refer to the previous video. Okay, 2 methyl. And at carbon number 3, we have, okay, 2 carbons, which means F. Yeah, F. So 3 ethyl. Right. And finally, time to combine. When we combine the names, remember, the names or the substituents are arranged in alphabetical order. We always consider the first letter except for the prefixes like di, tri, tetra, but we consider iso and neo. Yeah, iso and neo. No problem. We'll have a look at one more example later with that prefix. Okay, so considering M and E, yeah, which alphabet comes first? Of course, E comes first before M. Now, we can combine this all together. Pentane is the parent name. Then, we have 3 ethyl. And then, at carbon number 2, we have methyl. And finally, pentane. Methyl and pentane should have no space. So this is the IUPAC name of our structure. Alright? Okay. Now, let's have a look at the next example. Okay, the one that I told you before. I told you earlier. Which is F. F. Now we have a cyclic structure with 2 substituents at this carbon and 1 substituent here with a total of 3 substituents. Let's continue here. Now, we have a cyclic structure like this. Ada berapa carbon tu? 5. 1, 2, 3, 4, 5. So, automatically we know the parent chain is cyclopentane. Okay, cyclopentane. Why? Why is this the parent chain? Because it has 5 carbons. Okay. And the substituents ada only 1 carbon here and ini ada 2 sahaja. Right. This one is Br. This is 1 carbon and ini ada 2 carbons. Therefore, dia kalah. Siapa menang? 5. If the chain here is 6, this is going to be the parent chain. Sebab dia menang. So it's not that, oh, if it's cyclic, it becomes the parent chain. No. Dia bukan macam tu. You look at the number of carbon. Alright, so it's cyclopentane now. Done. This is our parent chain. Okay, how do we number our parent chain? Alright. Okay, you can start from any carbon, but remember, the aim is to give lowest possible number to the substituents or to the functional group. Okay, sekarang kita ada substituents lah. Remember, Br tu walaupun halogen, dialah functional group yang paling not reactive. Jadi kita always treat dia macam substituent sahaja. Right. Jadi, okay, we can start here. 1